Hello everybody, this is going to be a video sequence on Python functions. This is going to be a great tool that we're going to use over and over again. So let's jump in. Now if you're watching this video, you are likely in a math class, which means you already probably have a good sense of what a function is in a mathematical sense. A function in a mathematical sense is a tool where we throw something in, do an operation to it, and get something out. So you throw one number in, do some stuff to it, out pops a number. Or more generally, you throw in a thing, do something to that thing, out pops whatever, something else. In computer programming, a function is very much the same idea. You throw in a collection of things, you apply a bunch of code to those things, and out pops some nice result. So we're going to do this in a mathematical sense in this particular video, but then in subsequent videos we're going to look at slightly more complicated functions that you wouldn't think of as a mathematical function, but are definitely programming functions. So here's our first one. We're going to define the function, this cubic guy, x to the third plus some stuff, and evaluate it at some points. So here's how a Python function looks. I start with the word def for define, f of x colon. So I would read this as define the function f, I'm giving f the name, as a function that accepts x as an input. So I'm defining x, the name of the input. And now, just like all things Python, after the colon, I'm going to press enter, and then I've got a tab here that says what I'm going to do inside that function. So far I've said f is the name, x is the name of the thing coming in, and now I'm going to return x to the third plus 3 times x to the second minus 5 times x plus 1. So this is just like the idea you learned when you first learned about mathematical functions. You throw a thing in, that thing's name is x, into the thing named f, this thing's named f, and you return some collection of operations on that thing. So I can try it out. If I do f of 2.3, just like I would write it on paper, control enter, there's f of 2.3. Of course, I can make this look nicer by putting some text in there so I know what, oops, oh, f of 2.3. Oh, goodness gracious, because that's supposed to be the print command. That's what I was intending to do, sorry. So print f of 2.3 is equal to f of 2.3, and it does it for you. Well, what if I wanted to evaluate this function at several places? Now, there's more efficient ways to do this than what I'm about to show you. But that's for a future video. For right now, I'm just going to mash the keyboard and say, let's say I wanted to evaluate this function at those x values, whatever. For some reason, I wanted to do that. Well, I can write a loop. So I can say for x in my x values. And then I can print. I'll make this nicely formatted. For x equals x, f of x equals f of x. Now let's think about what this is going to do. For little x in that list, so it's going to do them one at a time. For x is 1, it's going to come down here and say the word for x equals 1, comma, space, f of x equals, and then it will go to this function and evaluate f of 1. Then once it's done 1, it's going to do 5, then it'll do 67, then it'll do 4, and so on. Control enter. And so I can evaluate the function in many different ways. And so if I had lots of different function values I wanted out of this function, I can just have the program go do it. Well, that's relatively convenient. Okay, this form of definition is a Python function. There's another one, so I'm going to squeeze in here a text box. A Lambda function streamlines the way that you write the definition. So we had our function here. Let me copy this guy. There's our function. Okay, we want that function. Okay, so I can do it as f equals. Now notice this is different than def of f of x. F equals lambda x, x to the third plus 3 times x to the second minus 5 times x plus 1. Okay, lambda is a little bit of an oddity in Python. It's just saying, okay, don't get hung up on the word lambda itself. It's saying f is a function of x colon, and then return this stuff. So lambda tells Python that we are defining a function, and we're doing so in kind of a streamlined way. So I can still come through and find f of 2.3 if that's what I wanted to do, or f of 784 if that's what I wanted to do. It doesn't matter. This is just a streamlined way to define a function, which is pretty slick. Okay, so let's do another one. Oh, and by the way, I should have said this. You should have a Colab document open. If you haven't yet, put me on pause, go do it. Go define this function in 2 different ways and play with it. Make sure that it'll actually work. In fact, a little exercise for you. Define this function as a lambda function and make sure that you can run this loop on that same function. It should work just fine. Once you've done that, let's go down to this one. Define the function g of n is n squared plus n plus 41, then evaluate it for every integer up to n equals 41. Put me on pause and go do this. Okay, now let's go do it. I assume that you've got it done. You can now see my solution. All right, so I'm going to say def g of n, and I'm going to return n to the second plus n plus 41. So now I want this for every integer up to and including 41. So for n in range 42, print g of n. Okay, so it gave me, let's see here, every integer. Oh, so it started at 0. Yeah, so boom, 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 boom. Here we go. All right, so there it is. Okay, now I could have, see if I comment those out. Oops, that's not what I wanted to do. Sorry. If I comment those out, I guess I would say G is lambda n. Oops, I actually messed that up. I am sorry. Let me go back. It's good to see when people are making typos here. That's to the second. There we go. The reason I kind of paused earlier is because I expected different answers and I didn't get them, and I didn't see why. I forgot to square that number. I just multiplied it by 2. Okay, so there's all my numbers. So now let's define that as a lambda function and make sure it does the same thing. So G is lambda n to the second plus, oh my goodness, n to the second plus n plus 41. And it gives me the same thing. So this is as close as we're going to get in Python to saying G is a function of n and returns n to the second plus n plus 41. Okay, that's the thing that we would want to write on paper, right? That's what we want, right? But this right here is not good programming practice until you know what n is. So telling Python that you have a variable sitting there, this is what a lambda function or a Python definition does. Okay? So one more example, and then, I don't know why that did that. One more example, and then I'll pause this video. We'll go on to more complicated examples in the next video. Let's define this function. It's got 2 inputs this time. So capital A and X. So I'm going to define f as a function of capital A and X. And it's going to return to me, oops, A times, ooh, sine. Sine is under the math library. I'm going to need to import math, right? Because I've got a sine function here. And now I can evaluate f of, see, I put the a first. So I want 1 comma math.pi over 3. There's one of them. F of, let's print that guy. 2 comma math.pi over 3. You know, I'm getting tired of the math dot. Let's do this. From math, import sine. From math, import pi. So check this out. Now I can come in here and do sine and pi without having to worry about calling them from the math library. Okay, and I can very easily evaluate this function at different amplitudes at pi over 3. Okay, I'm going to stop there. The next video has got some slightly more interesting function examples.